This is lecture number 3. And having this lecture number 3 shows the topic is nickel and its alloys. How this nickel and alloys will be helpful and what are the different applications. You can see this concept. The course name is Advanced Materials and Present Derivation of Partnership, course of Material. This all developed by the Jawaharlal Nehru. This is the nickel and its alloys shows the concept involved in this super alloys. Already we have seen the concerned topic in super alloys. Nickel and its alloys is also one concept topic related to nickel and its alloys. What is nickel and how these alloys will be? We have to understand this is nickel and its alloys is a family of nickel-based alloys. It is used in very and many engineering fields. And many engineering fields, and having this constant nickel and its alloys, the corrosion resistant and high temperature. And these nickel alloys are often known by trade names rather than the specification of code number. These nickel alloys having these different code numbers. And nickel based on super alloys also takes a major role for research and development for today's technology. And this some alloys are used in electrical applications such as heating elements. And here the magnetic characteristics of certain alloys are utilized in transformer components. And here the few alloys have controlled expansion and constant modulus properties. And these bimetals, thermostats, glass, sealing precision equipment. And how this nickel and its alloy plays a major role and how it will be manufactured. And we are discussing about this concept of this nickel alloys. It's having the general concern and having it will be developed for specific applications like hydrogen storage or to exploit a particularly peculiarity like shape memory. This views the main development of the applications using this nickel and its alloys. And here there are also a number of alloys used as building and brazing filler materials. And in this concept, you have to understand the logic of some nickel-based materials are applied as coatings or hard facing to other materials to avoid wear or corrosion resistance. And the nickel and its alloys, it is used for spacecraft. And here the nickel plating appears in many applications like electronics, thermal, control corrosion, production, etc. These nickel alloys are applied to subsystems requiring corrosion resistance, storage, and delivery system. And having high temperature performance often combined with oxidation resistance. And in these oxidation resistance, it will be interlinked to the propulsion units like gas turbines, rocket motors, power generation, and heat exchangers and heat turbines. It's having high reliability, high strength, fastness. And coming to magnetic alloys, to find a limited but important role, memory alloys may find use as actuators. In this, nickel and its alloys takes a major role, having the main categories like how the material will be useful and what are the main use of this commercially pure nickel, and is platings by electro or electrodes deposition. And it is useful to provide corrosion protection to the underlying substrate materials. And how this electroless nickel can be hardened to provide abrasion resistance and how it will be retaining corrosion resistance. And in this concept, we have to understand the nickel provides elevated temperature corrosion resistance to many acids. And it is a ferromagnetic care is needed in its use in some applications, electronics, some science missions. And the nickel-based materials can be grouped by principal alloying additions or additions, how the alloys within one composition grouping may be used in more than one general application. And here the nickel and its alloys having the resistance of nickel alloys to particular corrosive media largely depends on the composition. And this nickel based having the nickel molybdenum iron alloys often with additions of chromium resistant to high acid concentrations retained at high temperatures. It is also used in high temperature structural applications. And coming to the concept of nickel, chromium, and molybdenum copper alloys used to form mineral acids, many fluorine compounds, seawater often used as proteins. And also nickel, iron, chromium, Inconel 625 having resistance to inorganic and organic acid solutions, alkaline solutions, chloride ion, stress corrosion, especially seawater, Inconel 825 resistance to the strong mineral acids. It is useful for reducing the and oxidizing sulfuric and phosphoric acids at all concentrations to building oil. And coming to nickel, copper having the about 30% of the copper resistant to water and seawater non-oxidizing, and how these non-oxidizing acids useful and having the alkalis, many salts and organic acids, and having the nickel and its like having lower resistance to oxidizing acids. In this concept, we have to understand the heat resistant alloys to tend form to detailed independent groups. These are developed with the help of the service connection hard corrosion, resistant deformation in fracture under the improved service pressures and temperature, heat resistance in super alloys. Almost these all heat resistant nickel alloys are developments of the basic 20 nickel and 20 chromium composition. Modifications to the simple variations in the chromium content and the additions of the other alloy elements. And coming to nickel, iron, chromium, having usually with 15 to 20% chromium alloys are used at service temperatures up to about 1100 degrees centigrade, oxidizing, carburizing, sulfidizing environments, and also are resistant to other forms of chemical attack. And also having under thermal cycling for protective oxide layer may crack and spall. Generally, for any alloys or nickel-based alloys or anything, we have to understand the different applications. These nickel and its alloys having this heat resistant alloys having the more complex composition helpful for any engineering applications. And also, when we are discussing to improve the strength, similarly, the complex methods such as alloy increases the strength and temperature capability and that reduces the processability, and how these limits often taking place, and also sheet and complex forgings can only be made lower alloy and having the variance their temperature resistance is correspondingly lower. The applications are turbine blades. In these turbine blades having alloy selection is normally made on grip and corrosion oxidation requirements, but toughness and fatigue resistance are also important factors. And coming to discs, what are the discs that will be helpful? Alloy selections is based on the combined mechanical performance, creep and high cycle fatigue, crack propagation and fracture toughness. At service temperature, alloys with high iron contents and tend to have lower service temperatures, but conventional nickel-based super alloys it can operate at high temperatures. Coming to sheet alloys having the mechanical performance at service temperature and conditions is determined by composition of the strengthening mechanism used. Commercially available used for this solid solution like strengthening precipitation, then or oxide dispersive strength. Oxide dispersive strength ODS shows the capability of the sheet alloys. Sheet alloys are readily weldable with the exception of ODS alloys and Ring 41. This is the code used for the nickel-based alloys. Nickel-based super alloys possess good combination of high temperature and mechanical properties, operation resistance up to approximately 550 degrees centigrade. Many of these alloys having excellent cryogenic temperature properties. In this nickel-based alloys having the magnetic alloys, they have high magnetic permeability in low or moderate strength magnetizing, and it exhibits the particular magnetic species characteristics. In this nickel and its alloys having it mainly used for telecommunications, for electronic transformer components, pure nickel and some high nickel content. Cobalt alloys have magnetostrictive characteristics using calculators. In this control of the composition processing of the techniques used for the thermal expansion coefficient of some nickel iron alloys can be low or matched with the non-metallic materials. Some alloys can by the composition modification be strengthened, making them suitable for loading or bearing applications. Include vacuum equipment, metrology, and chronometry. And coming to positive temperature coefficients of elastic dampers. These materials find specialist uses in pens and vibrating devices. And this nickel titanium mirror alloys having 50% composition with respect to high heating and high temperature. And these are the processing assembly process with respect to methods of the techniques, similar process, all process, and applied for the aircraft and other critical industrial applications, and how the power generated for these nickel alloys. The precautions will be based on assemblies, brass terminals like nickel and the force vulnerability and thermal cycling, and different layer combination, service condition, and interfacial effects like thermal mismatch, diffusion, and how the barrier surrounding type coatings can crack and fall during thermal cycling, and how different elements of metal coatings can diffuse into substrate at prolonged elevated temperatures. And coming to this nickel based, the main research is going on with nickel based intermetallic alloys, and how this concept is useful for this growth and planar cellular and dendritic cellular liquid interfaces and depends upon the microstructures, characterization of nickel aluminum chromium based alloys, and how this treatment of nickel aluminum chromium based alloys, room and high temperature mechanical properties. These are the combination of elements like nickel, aluminum, chromium based alloys. This is the concept involved in these nickel based alloys having these super alloys.